Okay, so I just wanted to cover some of this stuff because I know um not many people were in class the other day. So yeah. So the first one is calculate delta A and delta G for a phase change. Keyword here, phase change, which means you know that delta G is going to be equal to 0. Because it's phase change. From there, your delta A is delta A to delta U minus T delta S. You can substitute because you know that delta U is equal to work plus Q, and that delta S is equal to Q over T. So then you can plug those in. Is work plus Q minus T times Q over T. Change color real quick. There we go. These two T's are going to cancel out, which is going to leave you with work plus Q minus Q, which is going to get rid of the Q's. Oh my gosh, why is this hard to change color? All right, I think I'm not going to be changing color very often with this. There we go. Okay, which leaves delta A is equal to work, which work is equal to, well, the derivative of negative PV, but that's going to become negative P delta V. Delta V is, you know, V final minus V initial, where V is equal to mass over density. Do note that you have your molar mass in grams, so that's going to need to become kilograms. So you could do that two ways. I'm going to do King Henry. So King Henry died by drinking chocolate milk. That's your base unit, which is your grams. You're trying to go to kilos, so you go 1, 2, 3 moves. And then you're going to move the decimal 1, 2, 3 times. So that's going to be 0.04402 kilograms per mole. You could also, of course, multiply the grams by, like, I think one with the 1,000 grams over 1 kilogram, and that should give you the same thing. Yeah. So then from there, your V's, I'm gonna just write it out at the bottom. It should give you pressure too somewhere. I believe pressure here is 1 atmosphere. Which you might need to convert depending on what your, I think 1 atmosphere should be fine. But yeah. So then you just plug in and solve for that. I'm gonna go ahead and erase this now. Okay. So for number 2, we're looking for the Gibbs equation for energy. Energy is U. And our Gibbs equation then is du is equal to T ds minus P dV. We're deriving with this, so du over dV at constant temperature. I like to think of it as just dividing each by V. So let's see if I can get this change color again. Here we go. So then to make this by dV, we just divide everything by dV. Which means that these dVs are going to cancel out. And we're going to be left with S dV. And of course, you've got to add the by T just to all of them. So that's going to give you, let's see where to put that. I'll put it up here. So that's going to give you over here. Actually, I'm going to put it up here. See if I can select stuff and move it. I don't think I can. No, I don't think I can. Anyway, that's going to give you T ds over dv T minus P. This here should look familiar. It is one of your Maxwell's equations, I believe. So that one is ds over dv at constant temperature is equal to P partial derivative of temperature at constant volume, which is also equal to beta over kappa. So then you can just plug that into there, which gives you your answer. Go ahead and write that here. So that's going to equal to T beta over kappa minus P. That's going to be your du over dv and constant T derivative. Yeah? Okay. Go ahead and erase that. Scroll down first. You guys have a little bit more time. Here we go. Okay. This is going to be a bit longer. Actually, quite a bit longer. So for the equilibrium reaction, we're going to start with writing that reaction out. CO2, gas, for 2, Cl gas. I'm going to do it by ice table. Because your initial is given here. You have 1 mole of Cl2, so you get 1 mole here. It's first placed into the flask, so that means that there is 0 Cl because it hasn't started reacting at all. From there, we normally do X. So I'm gonna do X for the ice table, but keep in mind that X is also equal to this squiggly E thing that you'll sometimes use for partial temperatures and finding KP. So I'm gonna just start using that squiggly thing, even though it's harder to write. You don't have any cofactors in front of the Cl2, so let's just minus that. This one you have plus, it's a 2, so it's gonna be 2, whatever the cofactor is. My squigglies are gonna be all bad, so I apologize for that already. So then your change is gonna be minus squiggly plus 0 plus 2 squiggly. Okay. So we'll put that in a box. From there, we can start solving for Kp. So Kp is going to be the partial pressure of the one gas, Cl2. Is it Cl2? No, I lied. Oh my gosh. So much disappeared at once. Okay. I'll write this line again. It's gonna be pressure. No, sorry, product over reactant. So it should be P of Cl over P naught squared, because the squared because of the 2 here. So that 2 makes it the 2 there, and then also we just squared up there. And then that's going to be over PCl2 over P naught. Right here, we can also already move the squared in. So we can move this in here. So we get squared and we get squared. And then from there, we can cancel out one of the P naughts. Note that P naught is equal to 1 bar. Just keep that in mind for when you're solving at the end. From there, you also know that it's PV goes in RT. But if you divide each side by V, you get P equals to nRT over V. So then from there, you can plug that in. So we've got the P. Let me just plug it in. No. Why did so much disappear? Oh my gosh. So we have the nRT over V squared for Cl. Put Cl there. Over P naught over NCl2 RT over V. You can consider that all over 1 because of the P naught. From there, just simplifying, it's just algebra. But from here, I know for sure that one of these RT is going to cancel out with this one. So let's move that squared in. And this squared. So then one of these is going to be canceled out by the one at the bottom. That's going to give us NCl squared RT over V over P naught over NCl2. From there, you can simplify that however you'd like. This is how I like to write it. So it's going to give us NCl squared RT over V over P naught over 1. So then that's just the top part. Then all of that is divided by NCl2 over 1. And I'm going to add the other one right now. So then these two are going to combine, and then these two are going to combine. And that's going to become NCl squared RT over VP naught. And then that's just going to carry over. So you still have that big, this is the divided by, I actually need to erase that. Why does so much disappear, I swear. T over, there we go. I'll put this one in yellow just so we see it. NCl squared over 1, 2, sorry. And these two are going to combine to give us NCl squared RT over NCl2 VP naught. Okay. And then from there, you can plug the NCLs in. So you're getting these from up here where this is NCl2 and this is NCl. So then you can plug those in. Actually, you could probably simplify first. Yeah, let's do that first. There we go. That's going to equal to Kp. And cross multiply that so that NCl squared RT is equal to Kp NCl2 VP naught. And then from there you can move this side over. So then we get 0 is equal to NCl squared R, no. I'm way over here. Oh my gosh. NCLRT. Okay. Kp NCl2 V P naught minus NCl squared RT. From there, you can plug in the n values and simplify. I'm gonna have to erase some stuff, so bear with me. Don't want to erase size table just yet. I'll erase this top part first. I also erase this side over here. We'll just keep everything except for Okay, I think that's everything. Zero here. Unfortunately, I cannot pick up stuff and move it apparently, so I'm just gonna rewrite it. And after all that, we get 0 is equal to Kp and Cl2 minus squared RT. I'll go ahead and erase this. So then from there, now we can plug these in. So this one's gonna come here. This one's gonna come here. So then we're gonna get 0 is equal to Kp 1 minus the E squiggly Vp naught minus 2 squiggly squared RT. And then from there, you're gonna add this squared in, and then you're going to, I'm gonna move this Kp over here just for visual purposes. And then I'm gonna factor that into there. So then we get 0 is equal to Vp naught Kp. I'll have to just erase this Kp. Just rearrange it. There we go. Kp, that's all 1 minus V naught, sorry, Vp naught Vp naught Kp times C squiggly minus 4 E squiggly squared RT. Now this might look a little familiar. 0 equals, I think it's C plus bx plus ax squared, right? Quadratic. Right? So that's exactly what you're gonna do. You're gonna plug stuff in for here and do your quadratic formula. I'll plug some stuff in right now. For 0. Your V is here. So let's put, there we go. V is equal to 2 liters. Kp is that big number right here. P naught is equal to 1 bar over here. What else am I missing? Oh, and then R is a constant. Which I believe in this case it is. Oh, can we read through that? Where's R? She gave you a few R's. I think. Is there one with bar? There's one with atmosphere and liters. Okay. She didn't give you one with liters and the bar, so we'll convert bar to atmosphere. And we'll use this one right here, the 8.20578 times 10 to the negative 2 liters atmosphere over K Kelvin times moles. And then it takes how many bars for 1 atmosphere? Okay. One bar is equal to 0.9 8, 6, 9. There's more numbers there, but that's what I'm gonna write. Cool. Let's bring this back down. Slightly higher. There we go. So let's click on those conversions over here. Your P naught's already 1 bar. So you should be fine there. We'll just plug this in as is. Your V's in liters, which is the units we want. Your KP's in, well, KP doesn't really have units. Your temperature's right here. It's already in the units we want, so that's good. What else do we need? We have moles. Okay, cool. So then we have 2 liters times, I'm just gonna put 0.987. No, I'll write the whole thing that I already shortened it. I'm just gonna put KP though, because that's a long number. P minus that same thing. Yeah, you guys can plug that in from there. And then you plug, change color, this in for your quadratic formula. C, B, sorry, it should be negative because you're including a negative in there. And then yeah, then you plug it into your quadratic formula, and that should be that. Ooh. Nice. Stop sharing real quick. Someone had a question on this earlier in the week, and I was unable to fully answer it, so I'm coming back to do that now. Because this is really similar to how it was. You have your initial moles. Or she does put that right there, so you can't really do the ice table right there. But then we could do the C. Where am I gonna put the C? Maybe I can zoom in here. Here's the annotation option. So this is gonna be minus 2, the thing. B1's gonna be the 2 because of the 2 here. This is just minus the thing. And this is plus the thing. So then that would make your NA equal to 3 minus 2 NB is equal to 2 minus and NC is equal to 5 plus. Cool. And then from there, you could probably start doing your KP. So let's do that. This is asking for that KP. We have products as PC, so it's going to be PC over P naught. All that divided by PA over P naught. Because of the 2 up here again, it's going to be squared. And then times PB over P naught. That's going to simplify into PC over PA over P naught squared. PB. Because P naught and that P naught cancel out. From there, you can plug in your P equals nRT over V. And you do the I because it's like for that specific compound. So then that's going to be NC RT over V divided by, I'm just going to leave the PA over P naught the same because that's not going to cancel out. It's going to cancel out with B. And then NB RT over V, which of those 2 are going to cancel out. And then that's going to get you NC over 1, how I like to think about it, over, we can put that squared in though. So PA squared over P naught squared V over N1. And you simplify that. I'm going to come write the simplifications over here. I like to do this group method. You could also do the reciprocal. So, or you could do NC over 1 times the reciprocal of the bottom, which is just the same thing on the bottom, but flipped over. So P naught squared over PA squared NB, which is going to give you the same answer. That's going to give you NC P naught squared over PA squared NB. Cool. And then that's still equal to KP. So you're going to move that over there. CP naught squared KP times PA squared NB. From there, you can move this one over there. So it's equal to 0 minus NCP naught squared. Probably should have written that in. Why does that do that? Oh my gosh. Anyway, I was going to write that minus NCP naught squared. So that it's equal to 0. And then from there, you could probably plug in your NC and goes in. I'm going to go ahead and do that now. So we get 0 is equal to AP times NA, which is 3 minus 2 N RT over V. That's still squared. NB. Oh, I'm plugging that in, never mind. Times 2 minus the E thing, minus 5 plus equilibrium composition, the E thing, P naught. From there, you simplify, simplify, simplify. Move those in. Move these into here. And then square it. Oh, jeez. I'm gonna just tackle this part first. So this one's gonna become 5p naught squared plus p naught squared, and all that's still minus. But I'm gonna tackle this part, so I'm gonna do 3 RT over V minus 2 squiggly RT over V squared, which is then gonna be 3 RT. I'm just gonna write this real quick. Okay. Sorry, I don't always, can't always do these right off the top of my head. Okay, so then we're gonna get 3 RT over V squared minus 2 times 3 RT over V times 2 E thing T over V plus 2 squiggly RT over V squared. Which I'm gonna need more space, so give me a second while I erase stuff. Why did I do that? Oh no, I need that equation. Got that all of it? Well, I think that should be most of that equation at least. This button alone. Okay. So let's rewrite that equation. Cos KP times what is now this part, because this part is what was here. 3 squared R squared T squared over V squared minus 2 times 3 times 2, which is 6 times 12. Sorry, 6 times 2 is 12, so minus 12. E thing, r squared t squared over v squared plus this squared, 2 squared is equal to 4, plus 4, e thing squared, r squared t squared over v squared. All that times 2 minus e thing. And then that equation is still longer. So minus 5 p naught squared plus squared. Okay, now I can erase this bottom part. These are very long problems. But I'm sure you guys know that already. Okay. So now we can factor this one in here. So I'll just keep this one in orange. KP times 9. I'm just going to keep this RTV squared because my brain finds that easier. Times 2. Oh my gosh. Oh shoot, I gotta go. I took too long. Alrighties. Let me just pause this. Okay, I'm back. Let me double check that I can hear him here. Can you guys hear? Yeah, cool. I started writing without redoing the recording, so I'ma just point stuff out. See if I can, okay. So this is our KP. I wasn't able to when I paused the recording, it erased all my other drawings. So this is where we're starting again. From there, you plug in your moles, which are here, right? From there, I decided to just take this bit here and simplify that. So this is just this squared here turned into that. That's in blue. And then I added in the NB, which that became this long thing here. From there, I grouped like these have no weirdy. These two have one. These two have it squared. And then this one has a cubed because of the factoring it in, right? And so then that simplifies down into this after combining like terms. So then from here, we do have a cubed here. So that makes the quadratic equation pretty difficult to use. So I would go by factoring. Let me change to actually writing with pen now. So I would probably factor these two together for sure because they have 4. 20 divided by 4 is, I think, 5. Yeah, 5. So then we can factor out 4, the e thing squared as 5 plus right? Which that makes sense because that's coming from here. Factoring out the other side is going to be a little bit more difficult. Because we have this 18 and this 33. The way I like to do these is I start dividing. So 33 divided by 18. That's going to give us, oh, it's going to give us 1.8. So that's not exactly a whole number, but it's also not bad. These two have 3 and this is 18. I think 33 divided by, we can test by 4. 4 is 8.25, and then 18 divided by 4, 4.5. You could actually probably divide those a little bit further down. We probably just leave it as is too. That might throw this off though. This is that. It's probably gonna be plus whatever this is. It's a lot easier if everything is multiplied by each other. Not gonna lie. Hey, Choco. Choco, Fizo. Choco. What? Sorry, my cat. Yeah. Yeah, I'm pretty sure from here it's just algebra. I do have to go again. But yeah, from here it's just algebra and separating it out, and something got erased in it. There it is. Okay, well, I'm back. I wasn't able to figure out how to factor this, so I tried to put it through Mathway. So I'm gonna go ahead and I'm gonna erase this screenshot first. Actually, I'll just leave it as is. And then I plugged it into Mathway. And it says you can't factor by grouping, and I can't be factored with rational numbers. So, I might have done an algebra error that you'll catch as you're working through it on your own. If not, I suggest just asking Dr. C because, yeah. Oh, you know what? I haven't finished the problem. Never mind. Let me work on that now then. So before we start factoring, that's just the bottom part. I got ahead of myself. I was excited to be done. My bad. So then that's just the bottom part, this part here. And that's going to be equal to KP times RTV squared. So then we're going to get KP times RT over V squared is equal to 18 minus 33 plus 20 plus 4 cubed. I feel like this is a lot of work for one problem. Equals, this top part's just gonna be the PO factored in. 5PO squared plus PO squared anything. From there, we can bring these in here. Factor those in. And move this over there. We'll do the factoring in first. I'll factor the squared in too, because why not? I actually don't want to write that many squares, actually. Just keep it. And then we're adding 5p naught, which will probably be here. 5p naught squared. And then this is singular. So that would be over here. And all that is equal to 0. And then from there, you can plug in your KP, your T, your V, your R, you're going to be based off your values. Your P naught is usually equal to 1 bar. You can convert that to atmospheres or torr, whatever units you need. I'll do this so you can see that those are their own. And yeah. I don't know. I hope that helped. I hope that didn't do anything bad. Good luck.